Hello guys, so তোমরা last video টা দেখলে, so what we will in continuation to in that video, today we will talk about ML6 geometries, right? So okay, so let's talk about ML6. Okay, now we know ML6 is basically nothing but the octahedral, correct? So if we draw the structure here, so how it will be like this, M correct, 4 axial and 4 equatorial and 2 axial, like this. Okay, now see, let's say your all ligands are different. Okay, all ligands are different, then what we will get, let's say L1, L2, L3, L4, L5, and this is your L6. Now let's say if I think in this way here, if all ligands are different, then these two are basically, we can say that R will be cis to each other, again L2 will be cis with L4, again L2 will be trans with L5. So we can get a different set of pairs, and from that different set of pairs, that means the number of cis pairs and number of trans pair, what we can do, we can get different geometries, and we can get different formations. Now see, in all the cases, if I talk about heteroleptic complexes, right, where the ligands are different, but but in a complex, if your all ligands are different, that's a very rare case, right? So here what we will try to figure out that one complex is a heteroleptic complex, right? Suppose it has 2 different ligand, or let's say max to max 3 different ligand, what could be its possible different isomers? Now the point is, these isomers, they has a different part. What is the different part? The different part is that compared to your geometrical isomers also, parallelly they are optically active also, correct? Let's see, we will talk about few of the examples, and let's see they are geometrical isomers, and the geometrical isomers are optically active or not. Let's focus on that. Okay, so let's talk about our first geometry, that is your MA4B2. It's a very important, where metal has 4A ligand and 2B ligands. Now what are these possibilities? Now the possibilities will be like this. Let's say let's say this can be one possibility, where all the A are in one plane, and the 2B are where 2B are opposite to each other. Now this molecule, we will say this is basically nothing but this is basically with respect to this plane, these 2B are opposite to each other. So basically this will be your trans geometry. This will be your trans geometry. Okay, now coming to the another one, if I think in this way, let's say the 2B are cis to each other, like this. This is also one possibility. This is also one possibility, right? Okay, like this. Now see here, interestingly, the 2B are cis to each other. So this molecule will call cis geometry. But is this molecule is optically active? No. Why I'm telling? Because if you see here, if I draw up imaginary plane here, this part and this part is mirror image to each other. So it is not a optically active molecule. And second, see this part, if I put a mirror here, if I put a plane here, this part and this part is the mirror image to each other. That means the molecule, both of the forms of the molecule contains a plane of symmetry, correct? So basically this is not optically active, not optically active. Okay, now let's move on to the another set of example. Let's see, next set, number 2. Okay, let's say if I talk about this complex MA3B3, it's a very famous complex actually, you know. So let's draw first M like this. This can be one possibility, where the all A are in one face. I will come to this, and all B are in another face, right? This is another one possibility. Now what we can do, we can just exchange one A with B. this can be possible. Let's see. This can be possible, correct? So I can write a B here, I can write a here, I can write the B here, and A is exchanged with B, so B here, no, not here, B here, okay, one A here and one A here. This can be one possibility. Now this part, if we see very clearly, the all three B are basically facing one face, that is this face, triangular face, okay, and all A are basically facing another face, that is this triangular face. This geometry or this molecule is called FAC isomer, or in short form the facial isomer or the facial isomer. Facial short form is the FAC. और दूसरा वाला क्या है? Here देखते हैं, this B are like this, is like this, माने if this is your geometry, the B is like this, and similarly अगर हम A को देखें, the A will be also this. So basically this is called meridional isomer or Mar isomer. Okay, it's called meridional isomer or Mar isomer. Right. अब next example, this is one of the variation. दूसरा example लेते हैं, अभी देखते हैं बच्चों दूसरा example. Okay, now let's say अगर हम ये वाला लेते हैं M A A, okay, एक हम बाइडेंटेड लिगेंड से भी काम करते हैं, B2C B2C, अगर हम इसको देखते हैं, okay, so what it will be, this will be MAA2, अच्छा C बाद में लेंगे हम, okay, C बाद में लेंगे, B2C2. So is this molecule what it will be? So let's draw. So M, similarly this will be your A, this will be your A, this will be your A, this will be your A. So this is one possibility where the 2B are trans to each other, where the 2B are trans to each other and the 2A are trans to each other, right? So this is called your trans geometry. This is called your trans geometry. तो दूसरा, अगर दूसरा वाला एक और possibility is there. So what is that? M. First let's draw. First we will draw, then we will put like this connected, and A this connected. So B are here, correct? So here if you see very clearly one thing, that the 2B are cis to each other, and your A is also, the bidentate ligand is also cis to each other, right? So this molecule is called cis molecule. Now see, we will see that this is optically active or not. Now definitely if we look it very clearly here, due to presence of this plane of symmetry, again this is not optically active. This is not optically active. But अगर हम इसको देखें ध्यान से, this one if I see very clearly, then इसको अगर mirror image if I draw, so what we will get? B metal, A connecting them. Now you see both of them are basically non-superimposable in mirror image, correct? Both of them are non-superimposable mirror image. So if this part is your D isomer, then definitely beta this will be your L isomer, and what we can say then, the cis isomer is basically your optically active. Cis isomer is basically optically active, correct? So for this kind of geometry MAA2B2, your cis is optically active, whereas the trans is not optically active. एक और देखते हैं, next last one we will talk about, okay? अच्छा, अगर बेटा अगर ये वाला होता तो क्या होता? MAA whole 3. This is a new set of variation. अगर हम देखते हैं तो let's see क्या structure है इसका. The structure is like this. M, पहले हम normal draw करेंगे. This is one we will draw. Now let's connect this A. Okay, let's join this, let's join this, let's join this. Now this is one isomer. Now see here beta, one thing very clearly, यहाँ पे you cannot tell this molecule as a cis also, yeah, trans also, because there is no set of geometrical variations are there. But if I put a mirror here, if I put a mirror here, तो क्या देखेंगे हम? If I put a mirror here, So we will get this molecule. Like this, right? So if this molecule is my D isomer and this molecule will be your, okay, so what we can say that for MAA3 complex, that is a metal having two bidentate ligands connected together, so it will be always optically active, but it will not have any kind of geometrical isomers. So it will be having D and L isomers. So what is the ultimate take home message from here? First you identify, first let's say your molecule is given to you. Now you identify it is in which category it comes, AA2 or AA3. Based on that, first draw the molecule. Okay, first draw the molecule. Then you try to identify that if it is having geometry or it is having optically, when your optical isomers. See, definitely one thing, if geometrical isomer is there, one of them will be optically active or one of them will be optically active or neither of them will be optically active. Okay, but the thing is that if it is optically active molecule or it shows optical isomers, not necessary it will show the geometrical isomers. So that is basically examples dependent. So my suggestion is that work on more and more examples. Okay, so if you work on them, you will be getting more and more different variations of there, and from there I'm sure this part what we have discussed today, what I delivered today, it will be completely helpful. Okay, so this was all of your part from the isomerisms in the coordination compound in the ML6. Hope you liked it, and if you have any questions, feel free to write in the comment box, share with your friends, and from my end, RGD Sir. So thank you all for the watching. Bye. Take care.